Imagine this. Your enterprise has built a powerful AI brain, a system that can answer questions, process data, guide decisions, create insights, and carry the collective intelligence of your organization. But now, the real question is no longer what the model can do. It is who gets to talk to it, who gets to influence it, who gets to extract from it, and who gets to quietly manipulate it without anyone noticing. Because today, identity is not just a username, access is not just a permission, and AI is not just another tool. AI has become the new nervous system of your enterprise. And every access point to this nervous system, every prompt, every API call, every session is a potential doorway to your organizational memory. As we step into this session, slowly, intentionally, with clarity, I want you to feel the weight of this question. Who gets to talk to the model? Because this single question will define the future of your AI governance, your data security, your compliance maturity, and your enterprise resilience. Over the next 20 slides, we will dive deep, layer by layer, into how identity works in AI systems, how attacks happen, how zero trust adapts to the AI world, and how you, as a leader, can build a future-ready AI identity architecture. So take a breath, let your mind slow down, and prepare to explore the new frontier of enterprise security, a frontier where identity truly becomes the new perimeter for humans, bots, and models alike. Across the world, enterprises are pouring millions into AI, building models, deploying co-pilots, integrating generative engines into workflows, and yet there is a quiet, invisible, but extremely dangerous vulnerability growing inside these organizations. A vulnerability that most leaders do not see until it is too late. It is the vulnerability of AI access control. Because unlike a database, unlike an API, unlike an application, AI responds to natural language. It carries memory, it adapts, it reasons, it generates, it reveals. And that means any unauthorized or unverified access to an AI system is not just a login attempt. It's a direct doorway into sensitive intellectual property, strategic decisions, internal knowledge, and even your competitive advantage. Every model interaction becomes an attack surface. Every prompt becomes a potential exploit. Every output becomes a potential leak. Traditional IAM frameworks, beautiful, well-structured, well-tested frameworks, were simply not designed for this world. They were built for static systems, but AI systems are dynamic. They evolve, they interpret, they generate context. And this is why enterprises are already seeing prompt injection attacks, role takeover attempts, data extraction through clever querying, plugin escalation, and silent credential compromise. The danger is not theoretical, the danger is active, and the average time to detect unauthorized AI access today is 127 days. That is why this slide calls it the silent enterprise vulnerability, because the greatest AI weakness is often the one you cannot see, the one you never instrumented, the one you never monitored, the one you never thought needed protection. But after today, you will never look at AI access the same way again. Redefining identity in the AI era. In traditional systems, identity was simple. A user logs in, an app calls an API, a permission is granted. But now, in the AI world, identity becomes fluid, it becomes multi-layered, it becomes contextual, because when a human interacts with an AI system, they do not just send a request, they send language, context, intent, emotion, patterns, and the AI interprets all of it. Slide 3 beautifully shows 4 layers of identity in AI systems: the human, the application, the model, and the output pipeline. And here's the hard truth. Identity verification can fail at any of these layers. For example, a human may be legitimate, but the application mediating their access might be compromised. The application may be clean, but the session token may be hijacked. The session may appear valid, but the prompt could be malicious. The prompt may look safe, but the model's output may leak sensitive system instructions. So the question is no longer who accessed the AI system. Today, the real question is who do we authenticate? The human, the application, the device, the session, the context, or all of them continuously, always, every single time. This is a new form of identity, one that is dynamic, behavioral, adaptive, one that requires deeper verification at every step. And as AI evolves, identity will no longer be just a credential. It will be a story, a combination of behavioral patterns, interaction context, device trust, risk signals, and real time verification. This is the true evolution of I am, from static controls to AI aware identity governance. The expanding universe of AI users. When AI enters the enterprise, the number of potential users multiplies instantly. You do not have one type of user. You have 6, sometimes 12, sometimes 30. Slide 4 shows beautifully how the AI user universe expands. Employees, developers, applications, bots and agents, external clients, third-party vendors. Each of these groups brings their own challenges, their own risks, their own access patterns. For example, employees use AI for productivity. They ask questions, request summaries, generate ideas, but they may accidentally input sensitive data. Developers go deeper. They interact with training data, prompts, fine-tuning, model configurations. Their access is powerful and dangerous if compromised. Applications access models silently in the background. A compromised API key here is an open gateway for attackers. Bots and agents, autonomous systems that execute tasks, are becoming a major identity risk. Because bots cannot recognize social engineering, they can be manipulated without even knowing it. External clients bring business value, but they must receive only the outputs they are entitled to. And third-party vendors, often overlooked, may have broader access permissions than your own employees. This expanding universe means one thing: your AI access control cannot be one size fits all. Every user type needs different authentication, different authorization, different monitoring, and different output filtering. If you treat all AI users the same, you create a massive blind spot. But if you differentiate them intelligently, you create a secure, resilient, and well-governed AI ecosystem. This is the foundation of modern AI identity architecture. The AI access attack surface. This is one of the most important slides in the entire deck because it reveals the true attack surface of AI systems. We often assume attacks will look technical, but many AI attacks look behavioral, linguistic, or identity-based. Here are the key vectors from slide 5 and what they really mean. 1. Stolen API keys. API keys are the modern master keys to your AI kingdom. Once stolen, attackers can quietly extract data, run malicious prompts, or even reconfigure model behavior. Second, token replay attacks. Attackers intercept session tokens and impersonate legitimate users without needing usernames, passwords, or MFA. Third, unauthorized plugins. Plugins extend model capabilities, but malicious plugins can perform actions far beyond what the model is allowed to do. This is one of the fastest growing AI attack vectors. 4. Role escalation. If RBAC or PBAC is misconfigured, an attacker can escalate from a harmless query-only user to someone who can deploy, modify, or extract sensitive datasets. 5. Lateral movement through model memory. This is the scariest vector. If model context is not isolated, an attacker can pivot through memory and access conversations, data, or system prompts that were never meant for them. And the shocking statistic, the average time to detect unauthorized AI access is 127 days. That means attackers can silently interact with your models, exfiltrate knowledge, probe vulnerabilities, and craft sophisticated prompt-based exploits for over 4 months without detection. The takeaway from this slide is simple and powerful. AI expands the attack surface in ways traditional systems never did. It requires new thinking, new identity tools, new monitoring mechanisms, and a zero trust mindset designed specifically for AI. This is the reality of modern AI security. Zero trust for AI interaction. Take a deep breath because this slide represents a massive mindset shift for your organization. For years, enterprises believed in a simple philosophy: trust but verify. But in the world of AI, that philosophy collapses. Why? Because every prompt, every message, every interaction is a potential threat vector, a doorway, a manipulation attempt, even if it looks harmless on the surface. The new principle is clear, the uncompromising, and absolutely necessary. Never trust a prompt. Always verify the identity behind it. Zero trust for AI is not a copy paste of network zero trust. It goes deeper. It stretches across human identity, application identity, session integrity, device trust, intent verification, and contextual behavioral patterns. And here's the truth: identity in AI systems cannot be a one time check. It must be continuous, contextual, adaptive. In real world AI operations, you must verify every layer of access. Who is the human? What is the session? Which application is mediating access? From which device? With what behavior? At what time? Under which risk signals? For what purpose? Zero trust for AI means assuming breach, assuming manipulation, assuming that the next prompt could be a threat until the system proves otherwise. And just like that, your AI ecosystem shifts from being open and reactive to guarded, intelligent, and proactive. The future belongs to organizations that master this mindset, because in AI governance, identity is no longer a checkbox. It is a living, breathing, continuously validated signal that protects everything you have built. This is zero trust, reborn for the age of AI. Access control model number one, RBAC for AI. Let's slow down and observe how traditional RBAC transforms when applied to AI. Most enterprises love RBAC because it's clean, simple, hierarchical, but in an AI ecosystem, RBAC becomes much more than just a role matrix. This slide reveals 5 distinct AI roles: AI user, data steward, AI developer, AI operator, AI administrator, and each role carries responsibilities that are more powerful and more dangerous than traditional IT roles. An AI user might only query the model, but even their prompts could leak sensitive information if misconfigured. A data steward touches training data sets, some containing confidential or regulated data. An AI developer can unintentionally alter model behavior through bad fine-tuning or unsafe system prompts. An AI operator manages deployments, often with direct access to production environments. And the AI administrator, they control everything if compromised. Your entire AI ecosystem becomes a playground for attackers. This is why RBAC alone is not enough. But RBAC as a baseline gives structure, order, clarity. When done right, RBAC provides a strong backbone for AI governance, ensuring that no one receives more power than they absolutely need. And yet, in dynamic AI environments where users, applications, and bots constantly shift roles, RBAC must evolve. It must be combined with ABAC and PBAC to deliver a dynamic, context-aware safety net. Think of RBAC as the skeleton, ABAC as the muscle, PBAC as the brain. Together, they create intelligent access control for the new era of AI-driven enterprises. Access control model number 2, ABAC for AI now. We walk into the world of attribute-based access control, a world where access is no longer binary, but deeply contextual. ABAC allows your system to decide access based on who the user is, what they want, where they are, how risky they feel, and what the data or model represents. Imagine an identity system that thinks like this. Yes, he's a data scientist, but he's accessing a highly sensitive model from a personal laptop on hotel Wi-Fi. at 11:48 p.m. at a location he has never visited before. So deny access and alert security. This is not the future. This is ABAC today. In AI systems, ABAC evaluates four primary types of attributes: user attributes, department, seniority, clearance, behavior history, dataset attributes, sensitivity, residency, compliance tags, model attributes, risk classification, version capability level, environment attributes, device trust score, network posture, geolocation. With ABAC, access becomes personalized, adaptive, risk aware. It protects your AI systems not just from malicious actors, but also from well-intentioned employees making careless mistakes. Imagine the impact. When every AI interaction becomes a decision based on real-time identity context, this is why ABAC is becoming a core pillar of enterprise AI governance. Access control model number 3. PBAC for AI. Now we step into the most advanced layer, policy-based access control. PBAC is the highest form of access intelligence because it encodes business rules, governance logic, and compliance requirements directly into the access system. PBAC lets you say things like, finance users can only query financial models during business hours. Any prompt containing PII must pass through masking filters. No external user can execute API-heavy queries without dual authorization. Code generation outputs must go through automated security scanners. This is powerful, very powerful. With PBAC, your enterprise begins to enforce access not only based on identity, but based on intent. It evaluates the purpose, the content, the risk, the context, and the compliance implications of every AI interaction. PBAC follows 4 stages: define, evaluate, enforce, refine. And here's the beauty. PBAC allows AI systems to evolve gracefully. As your business evolves, as your regulatory environment changes, as your risk posture matures. But PBAC also requires discipline. Poorly written policies, conflicting rules, or overly restrictive controls can bring your AI operations to a halt. It must be designed carefully, reviewed continuously, and optimized intelligently, because when PBAC works, it becomes the heart of AI security governance. API security for model access. API security is the lifeline of enterprise AI systems. Almost every enterprise AI interaction, whether internal or external, flows through APIs. This makes APIs the most targeted entry point for attackers seeking to manipulate models, extract data, or impersonate applications. This slide highlights key components of secure API access. 1. API keys. These must never be static, never be hard-coded, never be shared, rotate every 90 days, or faster for high-risk systems. 2. OAuth 2.0. This enables delegated access without exposing credentials, perfect for third-party integrations or large-scale ecosystems. 3. JWT tokens, cryptographically signed, lightweight, self-contained, but they must expire quickly to prevent replay attacks. 4. IP allow listing, a simple but powerful guardrail, only allow model access from approved IPs or trusted geographies. 5. Rate limiting protects your AI infrastructure from abuse, automation-based attacks, and runaway costs. API security is not optional. It is not a developer concern. It is the foundational gatekeeper of your entire AI stack. If your API layer is weak, your entire AI ecosystem becomes an open fortress. But if your API layer is strong, identity stays validated, sessions stay secure, and your AI models operate within a tightly governed boundary. This slide is a reminder. AI is only as secure as the API that protects it.